Okay, Paul here, and today we're going to look at this Zenith antique radio console here, and it's huge. And so I'm going to go ahead and pull it out of its case and set it up on the bench, and we will take a look at it and see what we can do. We're going to be repairing it, recapping it, and putting in a Bluetooth unit at the end. So bear with us, bear with me as I get it set up, and we will continue. Well, here's the Zenith out of its case, and it is a monster. And what it says, oh, look at this, it's got, turn that so it's centered there so I don't accidentally bang it. But we have foreign, high fidelity, bass, normal, and voice settings. And look at that huge dial. That's just beautiful. Beautiful dial. And has a scaled volume control here. There's 3 controls on this. And I would imagine this is the tuning, which has the clip that came out of the original, out of the button. No, that's, oh, I see. That's the selector for on local, on distance, and off. So that's the on-off switch. Okay. And let's see. This would be the volume, I would imagine. Yeah, and one of these is probably fine-tuning. It's not seeming to do anything. That one I can't turn. I'm not strong enough. This is switch here. So I took all these off, and we have to figure out what they do yet. This little spring fell off the bottom while I was moving it. It broke. It's broken. So apparently it was just hanging loose, and it just, fortunately, it didn't fall off till I got over here. So I was able to see it. And it's got one, looks like a tube socket that's empty, but I don't think that's actually a tube socket. I don't think it's connected. Speaker jacks in the back. Okay, back to what it says. Zenith long distance, made in United States of America. Wow, this is old. Patent, U.S. patent number, and it has a patent number, 207-8031. Looks like 207, let me get my magnifying lenses here and find out what exactly this says. 8031, yep, 207-8031. So we'll pull that up and take a look at it. And you see it has all of these station call letters all the way around the dial, which are probably from all over the place. It has the old police band, some kilocycles, of course, because that's what it was for standard broadcast back then. It's kilohertz today. And, of course, it has shortwave. So let's take a look at it. I'll get the schematic because I'm going to need it. And we'll take a look underneath in a minute. Has a magic eye tube here. And you see it hasn't been messed with in a while because you can tell by the dust. It has its original tubes here. Okay, so it's 2, 4, 6, 7, possibly 8 tubes. Looks like 7 tube set. And had some notes that came with it. Oh, yeah, where it was purchased, and this is the original tag from it. It's a model 9S262, 117 volts, 50 to 60 cycles, and uses Zenith tubes, of course, made in USA, Zenith Radio Corp, Chicago, Illinois, and then it has all of the patent numbers. And the most recent patent number on there that I'm seeing looks like 2072. I mean, 2,072,000. I don't see anything newer than that. And this one was 2,078,000. So this is the most recent patent for this device. Also in the bag we have the cans for the tubes. So we got 2 cans in the bag here. Shields, rather. Nice looking shields. Those are cool. They got holes in the side to let the heat radiate out. Okay, and that looks like it in the bag. Okay, that came along with it. So we'll put that in the note in there where it'll be protected. And we'll take a look at the bottom in a minute and see if anybody's been in this set. Okay, I'm on the U.S. Patent Text patent website, and that patent number 207031 pulls up a date of April 20th, 1937. And of course it's an image patent because it's before text. It's from microfiche, and the government just put them all on the patent site as images, and now they give it to you in a PDF format, which is really neat. That's a step up. Used to be you could only see the images on the website with a special software, and it was, which I have, but it just doesn't look as nice. There's the dial. So the dial is what it was patented. And there's the inventor, Kurt Arnold. I don't know how to pronounce that. Oh, that might be EMDE? EMD? I don't know. And then the attorney that signed the document. So there's the dial with the specifications, and it was filed April 20th, or the patent was issued rather, April 20th, 1937. It was filed December 3rd, 1936. So this is a 1937 radio, or 1938, most likely 1937. And it's 1 page. I thought it had said there was 8 pages. I'm going to go back and take another look at that. But it dates the radio. So it's a 1937 radio, Zenith. And that's about the age I thought it was, judging by the tubes. It's mid-30s. It's a little bit later than the 20s, when they were much smaller, but not as old as the first tube radios, which had much bigger transformers on them. See, that transformer's not that gymongous. It is big and it is heavy, but it's not as heavy as some I've worked on. It's weird, it does say section pages, 1 of 8 pages, but there isn't 8 pages, so I don't understand. Oh, maybe you gotta click here, something new, and go to page 2. Let's see what that says. Yeah, okay, so they got separate PDFs for each page. So let's take a look at the second page. Okay, and it's a side view, more of what's inside of the dial and the controls for it. So it shows you how the string is wound here. Let's see what else we got. We go to page 3, take a look at it. It's good, it's fun to do this because you get to see what was originally done. Okay, and there's the sections of the dial. So that's how they did copyrights back then in the day. sheet 3 of 3 on the dial. Let's see what they do after the dial. They probably have something else. Apparently there's 8 sheets. Wish they would have just joined them all into one PDF file. There's the patent information. And it's the dial mechanism. This invention relates to the dial mechanism and more particularly concerns dial mechanism adapted to selectivity display selectively display different frequency band scales to be used in tuning so-called all-wave or multi-band radio apparatus. And there's the official Zenith radio assignment when Kurt sold it to Zenith Radio Corporation, or probably worked for Zenith Radio Corporation. He's the inventor of the dial. And this document goes on for another couple pages, and I'll probably pull it up for the owner just so that they can have it. There's 4 more pages, which is mostly going to be technical data, like we just were looking at. That was just the intro. But isn't this something? This is how patents were done, and you can see it's just a screenshot of an actual printed document that was made in the early days and then put on microfiche and then finally scanned into, put on a projector and photoed or scanned to a document, a picture document, and then now that picture document has been rescanned into PDF because they were still back in the day in the older scan. Not too long back, actually, when I was pulling up patents. So you see how it continues and it gives you all the information. I'm going to go ahead and pull up page 6, 7, and 8. I don't know if I can select more than one. I don't think so. Full pages. Okay. They got a link here to what looks like the entire document in one PDF. Good. Okay, and there it is. Yep, there's the whole document. Awesome. And there's the inventor's signature at the end, the typed text, basically. Okay, so the next thing we got to do is pull up a schematic for it. But before we do that, we'll go ahead and take a look at the bottom of the unit. Let me get it flipped up on its side and we will see if this unit has been tampered with in any way. Well, here it is, and it looks pretty good. Somebody has been in here. You see there's a cut wire here. This band is broken off the tuning here. This leather, the glue let go at some point in time. That wrapped around there and went to something that I don't see. Oh, probably this motor up here. Oh, look at that. It actually has a motor to turn the tuning. Oh, that is awesome. That's awesome. We will get that motor going if possible and try to find a belt that'll work. I don't know if I can repair this one. It looks pretty damaged. Don't know. Maybe. But somebody's been in here because these got tape on them from years gone by. Somebody's done something here, repair to probably the rectifier tube. And actually, no, that can't be the rectifier tube. Yeah, it could. Where's the line cord? Come in here. Oh, we got a serial number on the side of the chassis here, riveted on. Yeah, the power cord comes in here, goes here to this on-off switch, comes back, comes to here. Well, this is probably the rectifier tube up here, maybe. So this is whatever tape they had on here came off. See, they had taped it there. I'm sure they had taped it in both places like they did here when they worked on it. And so that wasn't a wire, that was, this wire is cut though. I don't know what that went to. We have to find that out. So somebody's been in here and they've done some things. This doesn't look like an original Zenith. It's old, but it does not look like an original Zenith capacitor. You see these are all the Zenith paper wax capacitors, and they'll say Zenith on them. There's one back there that is a Zenith, but it's not from the same, not the same kind. It was added later, going to ground. That solder joint don't look that old, but they probably added in that other capacitor across across this capacitor, might have been out of tolerance. We have these, which look like some really weird resistors. They may be original, I don't know. They got color band on this one, 25K. I don't know about that one in the back there. It's kind of weird. It's got like a paper foil wrapped around it. Still starts with a red band, but I don't know what that is. It's probably a capacitor. Oh, it's a 25 meg. A 25K resistor probably. It says M for meg, but it would be more likely K. That one up there, some animals have been chewing on it. But almost all of this is original. It's got dog bone resistors here, so these definitely were added later because they're not dog bone resistors. And dog bone resistor down there. It has a Bradley resistor here that was added at some other point in time. So somebody's been in here a couple of times. You see the, looks like this wire might have actually shorted at some point here. Or either that or some wax or something dripped from up there, because it might be just wax. And so the line cord had been replaced, obviously. That's not an original line cord. It's a replacement cord. And that was added quite a while back, quite a ways back. You can see that it's got cracks in it. And it's a rubber cord. I would say it's probably a 50s, maybe a 60s. It looks like a 1950s cord. It's got a ridge on one side, so it could be 60s. But it feels rubber, it doesn't feel plastic or vinyl. So that was replaced. There definitely was a tube there, because that's a tube socket with connections going to it. So we have to find out what that tube is that's missing. What I'm going to do is pull up the schematic, see what I can find there. I don't know what this is all about, but it's got a metal strap going across both sides to the tuning condenser. Yeah, we'll pull up the schematic first and take a look at it, and then the second thing we'll do, let me take this off so I don't lose it. Second thing we'll do is check the transformer and these coils, IF coils, and make sure they're okay. And once we get past that point, the next thing would be to bypass these two electrolytic capacitor cans. There's one here and there's one here, and they would have to be replaced with modern day electrolytics before I even consider putting this on my Variac and bringing it up. We definitely want to get this motor running if possible. It definitely needs to be serviced. It'll have to be taken out and oiled and cleaned and oiled because it's not spinning. But it'd be interesting to see how that was set up to work. Fascinating, right? I mean, what were the engineers thinking when they designed this? It's amazing. Things we made in the United States were just incredible. So let me get the schematic so we can make sure we're checking everything the way we need to, getting correct resistances and things. Not that I expect too much listed on the schematic. We definitely need to see if this gigantic bar resistor that's bolted to the chassis here, welded to the chassis, we need to make sure that that's not drifted. They usually drift in value. If it has, we'll have to replace it. And today's contemporary power resistors have much to be lack a lot when it comes to heat dissipation. These jokers here dissipated a tremendous amount of heat through this chassis in a very efficient way and stayed cooler than the modern ceramic or cement power resistors, which are really smaller in size, and so the heat is concentrated. If that becomes a problem, we'll have to find another way to drop the voltage, because I have yet to see one of these of this age that was any good. They've drifted so far out. I'm not seeing nothing soldered to this end. However, there was something soldered to this end at one point, and I'm assuming that these resistors here that are in parallel and come into this connection here, probably, and see there's some kind of metal tab there, probably at one time was connected here. I'm pretty sure that's the case. It's connected there. And so it broke off, and they just jumped the resistor across, because this part is probably bad. This is probably bad, but was probably bypassed somehow. There's another Bradley style. Actually, that's a pre-Bradley style resistor there that was added. So there might have been some resistors put in to take the place of this, and I think that's what these are. This one here is a air-cooled power resistor. That's not original. So all of this was to repair the damage done to these. Like I said, these things got so hot, they just didn't last. But they were, when they were working, they were very efficient at heat dissipation. But they still got hot. You're talking a lot of power, a lot of voltage drop there. So let me pull up the schematic and we will continue. Well, I found the schematic for this 37 Zenith radio, and it is a 9-tube set. One of the tubes on here is a little short guy covered with dust, and I didn't see it, but yeah, and the one tube is missing, which is the audio output tube, which is this power output tube to pentode 6F6G, which is 6F6 glass is what that stands for, and that tube is missing, probably because they couldn't find one. They're not as common as the alternative, but the alternative is louder, so I'll probably use the alternative, which is a 6V6. Now this radio came with, well, this schematic has two sets of chassis. Is a 5905, which is this chassis, which is in the radio we're working on, and then there's the 1204 chassis, which is a 12-tube version. You can see it's the same chassis, same setup, but it has additional tubes. There's 4 additional tubes in it. So this is a 12-tube version. This is the one we have, which is the 9-tube version. So there's 3 tubes different, not 4 mistaken there. And you can see them, they're right here, 6J8, 6J5, and a 6K7, those 3. Oh, no, take that back. It has a pair of 6V6s for push-pull on the output. So it has an extra power output tube, a 6V6. So it's these 3 are not in here. This has a single 6F6 for the output. But what I was saying is we can substitute a 6V6, which is a beam pentode output tube, for the 6F6. 6V6 will draw less current from the transformer, which will make it run cooler and extend the life of the transformer, which is a good thing. And because it uses less current, it also has a higher amplification. The bias resistor may be different on them, but I can deal with that. But so there we have it. We now know what the missing tube is. We know what's been worked on, and this will be part 1 of this radio, video. And what we're going to do next is check the transformer and make sure we don't have a problem with the transformer. So we're going to have to find out what there's 4 coils in this transformer. There's the input, there's the high voltage output here with a center tap for the rectifier tube here, and then there's the filament voltage for the rectifier, and that goes up to all through there, of course, and then this goes to the dial light and to that funky motor assembly, which is probably providing, okay, the filaments are all 6 volts, so they're all in series string to ground. They're going across here. So the dial light, this goes to the filaments, and then this is the ground. So this is the 6.3 volt winding that powers all these 6 volt tubes, and they're all in parallel, which is good because that means that we can pull a tube out and isolate part of a circuit and test individual parts because the tubes are independent. Anyway, there you have it. So I'm going to set up to check this transformer, and we're going to see if we have any continuity across those coils and why that green wire is disconnected. I'm thinking, I'm not sure where that's supposed to go. We'll have to find out. I'm not seeing on here what wire could be eliminated. Unless it's one from this switch here. Might have been rerouted somehow, which goes to that motor assembly. Maybe that's disconnected. I don't know, but we got to figure it out. So that's the next thing, is check the capacitor and then check these IF coils. Okay, it's a good thing I didn't go ahead and order any tubes yet. I was going to order a 6V6 to replace this output 6F6. So to test the transformer, the first thing I wanted to do is pull out the rectifier tube, the 5Y4 here, right next to the transformer. That's this tube here, right next to the transformer's here, and there's the other tube right next to it. So I pulled that tube out, and it is the 6F6G. That tube does not belong there. That is the rectifier tube socket. This tube belongs way up there. So I'm going to have to pull all the tubes out and test them anyway. I might as well go ahead and set up and do that and just rule that out. But yeah, they have a 6F6. They just had it down here by the transformer, which is where the rectifier tube goes, and you can see because the filament for the rectifier are these two that come right out of the transformer, and the power cord comes in here, goes to the transformer, and it comes in here. This one here goes into the transformer, and this one goes to the switch, comes back from the switch, and goes to the other side of the transformer. So these are the two inputs for the 110 volts, 120 volts input. And so they go into the transformer, and they also connects up here to this motor or generator device, and it also connects to this switch here, which is one of the switches on here, probably this one here. No, it ain't that one. Must be this little one in here. It goes all the way through and turns back here. That's that wafer switch. So, but this would be the rectifier because this filament line comes here and goes nowhere else. And all the other, well, all of the filament lines are in parallel. Actually, this one does have, no, it does not. It's just those two. Boy, somebody's been doing some sloppy solder in there. And then these two come from the transformer as well. They go up there to the capacitor, one filter capacitor, and the other one, so that one goes to the filter capacitor. This one here goes up here to ground on that same filter capacitor. So that's the other reason I don't want to plug this in until I change those filter capacitors, because you got to be careful. A bad shorted filter capacitor is a dead short across the transformer winding, can burn out the transformer. So anyway, they had the power tube in the rectifier socket, which is a common mistake I've seen before, but usually when they're really close to each other. And this one, they're nowhere near each other, they're at opposite ends of the chassis. So that's kind of fluky. But anyway, I got the rectifier tube out, so I'm going to start ohming out the transformer. I'm going to just go ahead and, well, I don't even know if we have the rectifier tube now, because that was the power tube was in there. I don't think we even have the rectifier tube. So I'll have to check the tubes and order the tubes I want, but I want to make sure that the coils are working first. So the first thing we want to do is check across the input, the primary side. So let me go ahead and set up my meter and we'll go through these. Okay, I got my meter zeroed out pretty much. Oh, moving the cable here, it's messing up my, let me get this set up. Okay, let's try that again. Okay, it's zeroed out. And if we go across this input, we got 2.9 ohms. Okay, we're getting very low resistance here. This is the filament string line, so that would make sense because it's checking right across the filament of all the tubes. So that's, we know, is the filament string line, and I can pull, instead of just pulling out the tube that I did, I can unsolder this and check it later. Let's continue. We've got this one, which is a center tap for no doubt one of these. I don't know which. Because those wires there are one set, and this group of wires is coming out of a different port on the bottom of the transformer there. So this green is a, let me see if I can see that on the schematic here. I'm not seeing a center tap. That's what's so weird. The only center tap is on the rectifier tube. Here. There's two there. And there's these. I'm going to see if I can figure this green wire out. I'm not sure where that goes. It's a center tap for something. I'm going to strip it and see if it connects to that one. Hold on. Okay, so I'm getting about 148 ohms across this set of wires coming from the transformer to the rectifier tube. On this one, which these go to the filament string, I disconnected it to get a reading, and this is not accurate. 0.2. That's not accurate because if I connect dead short across my leads here, I'm at 0.2. So if that's accurate, I got a problem. I'm at 0.1. Let me zero this. Okay, so 0 ohms there. And if I go from here to there, missed it, try again. That's by the time I get it, my meter changes. Okay, so I'm getting 0.2, which is almost a dead, look at 0.1. So it's pretty much saying that it's a dead short. Now it is a very small coil, so I'm getting 0.1 there too, and I just short out my terminal. This meter is not that accurate that it can measure a part of an ohm accuracy. Okay, 0. And come over there. And it's about 0.1 when it settles in, or 0.2. Okay, so there is a resistance there, and this is a center tap for that coil. Oh, it's connected to that coil. So that's kind of strange, because now that I look at this, I'm really wondering, I think somebody changed this transformer, and that's why this wire was cut. Because you see, it looks like there was a bolt here, and of course this transformer doesn't bolt to that. There is a bolt here, but there's 1, 2, 3, 4 holes. It looks like there was a bolt on that one at one time. See, it looks like a lock washer or a washer on both of those. They don't have it. And that one has a bolt. And that's it. So, and there's a sheet metal screw coming down here, which really doesn't make a heck of a lot of sense. I'm thinking somebody changed this transformer. I don't think this was the original transformer. So that makes it more complicated, because I'm not going to get the exact readings I'm expecting to get on this transformer. We got this is the coil coming out. Yeah, somebody changed this transformer. That's why these wires are taped here. They actually replaced the transformer. That's why we got crappy solder jobs up here. Somebody changed this transformer. That's going to make it more difficult, because I don't know what they're supposed to be doing. Okay, so we got the input coming here. We got 2 wires going here to this tube here, which, okay, since that's not the right transformer, and I am getting resistance readings, but they're very small, I decided that I would just go ahead and, I got the rectifier tube out, so I just went ahead and put it on my current limiting circuit on the variac. And right now, I was checking this wire. There's 3 wires coming in here. There's that one in the back there, that tan colored wire. There's this black wire, and this tan colored wire here, which goes up to there where my alligator clip is. Actually, it's just chassis ground. If I bring the voltage up there, you see the transformer is putting out voltage, so it is working there. And if I bring this down to the other of those 3 wires here, which is this one up here, okay, and bring the voltage up again, you see it's putting out voltage. Okay, so those three wires are tied together. One of them is a center tap, probably the one that goes up there to ground on the on that capacitor. I just did this because it's easier than trying to check resistance. If you got a current limiting resistor thing on, light bulb, and you just bringing the voltage up around 30, 40 volts and checking that voltage is coming out, you're not hurting anything. I also did verify, so I verified those two, and then I verified that the transformer is putting out voltage on this filament line for the rectifier tube. So you see I already got 6 volts. It's jumping around, but it's about 6 volts. There we go. Maybe one of my leads might be a little loose, but it's about 6 volts. And if I bring the voltage up, you'll see it goes up. So that's working. The only other wires coming from the transformer besides the two going in, the input, are these three here that we were looking at earlier. I disconnected that one temporarily, and now I just reconnected it because getting a better way of doing it this way than I was trying to read the resistance on such a low resistance coils. Okay, so if I bring the voltage up here, this is a filament string. You see it comes up, and it won't come up very high because it's a filament string. It only max out at 6 volts. The wire that wasn't being used here is obviously a center tap of that same filament string. So let's bring it up to about 5 volts. Okay, there we go, roughly 5.5 volts. Still climbing, so a transformer is leveling out. Okay. So it's leveling out. There's a capacitor building a charge somewhere for 5.8 volts. If we now measure here, we have 1 volt. So apparently that's the center tap off that transformer. They're using half of that particular coil, 1 volt. And here, 0.6 volts. It dropped down. That's weird. Still working, so it might be my meter. Like I say, it's been fluky. I think I need new batteries. Okay, it's coming up. All right, so we got 1 volt there, 1 volt AC there, and of course here we got 2 volts. So okay, that's the center tap for that string, and it's not being used. That's why it was cut. So this transformer is putting out voltages. I don't know that they're exactly right, and I'm not going to know it until I change those electrolytic capacitors. I am not going to power the system up with the potential of a dead short across one of these capacitors. Now with the rectifier tube out, it probably isn't going to matter because there's nothing going to the capacitors except here through the rectifier tube, right? Because the others are filaments. There's not going to be any filament string connecting to the B+ line. And here we got, I still, just to be safe, I just soon change these capacitors. It's a good habit to have. It looks like we've got 1 capacitor in that can, maybe 2 if you count the ground. So 2 capacitors in that 1 can, and the other can is behind all this gobbledygook somewhere. Let me see, where are you? Right here. It's right here, behind all this. And we got 1, 2, 3, looks like 3 wires coming out of that can. So we have 3 wires coming out of that can, 2 out of this can. That would be This could be one capacitor. They may not be grounded. I'm not sure. I go back. Okay, here we have, according to this, we have 2 in each can. I'm sorry, we have 3 in this one can because it's got its own part number, and 1 in this second can. So C18 is a dry electrolytic 12 microfarad at 450 volts. And C19, 20, and 21 are in this part number, so they're in one can. And there's a 2 microfarad, a 6 microfarad, and an 8 microfarad at 400, 200, and 400 volts. So, 450. So this one that has 2 wires coming out probably doesn't use the can, and that's probably the 12 microfarad all by itself. And that would make sense since it's the highest one. It's a 12 microfarad. And then the other can has 3 wires coming out. It probably does use the ground, and it would have one, each one would go to the ground. And looks like there's a tie strip tied right to the area. And one of those wires is going directly to that tie strip. The other one is here. Yeah, I would think that's ground. So I'm going to take these cans and covers off these cans and see what in the world they're saying they are. But I have a feeling this is the 12 microfarad and that's the other 3. And we'll have to identify them by the color code of the wires. There's a black, a red, and a sort of a greenish color. This blue I don't think comes out of there. No, it goes across over to the other side. And this one has a black and a white. So yeah, I'm thinking this one is one capacitor, 112 microfarad right here. And this black is going to that terminal strip, which should be the ground. Where's this one going? This one's going to the ground. Wait a minute. No, neither side is grounded on that can. So that's a floating. And let's see, is that floating on here? Yeah, they're floating. They're not going to ground. They're going to ground through this resistor here, but they're not grounded themselves. Okay. And yes, my batteries are dying in my meter. So I have to put some new batteries in there. Okay, I jumped across some of these wires here and found some that connect and some that just seem to be not connecting. But usually IF coils are fine. I'm not going to risk worrying. I mean, I'm going to just take the risk and not worry about them right now. You know, there's another one up there that needs to be checked, and you know, this one just has so many wires going into it, and you know, and then they got the grid wires coming out the top. So I'm not going to worry about them. I'm more concerned with getting this powered up and seeing if we can get some noise out of it. So the first thing I'm going to do is work on these capacitors. I'm going to drop this down and take a look at those cans and see if they're marked, and then we'll go from there. So anyway, that's where I'm at. I'm going to flip this down and we'll be back. Okay, I got it flipped down, and I can already see that I was correct. This one would be the 12 microfarad. And there it is. So you can probably see that. Let me see if I can get the light closer to that. So the 12 microfarad and 450 volts. And then this would be the other 3. A lot of dust on it. Actually, it looks like 2. Looks like a 8 microfarad, or does that say 2 8 microfarads at 450 and something at an unreadable 200 volts. Yeah, that bottom one is 200 volts. And that looks like 2 8 microfarads. Let me see. What do we got? According to this in that can, a 6 and an 8 and a 2. And the 6 is at 200 volts, so it's a 2 and an 8. That's what that says. See? It says 2 and an 8 at 450 and 6 at a 200. So there's our filter capacitors. And this one's the 12. And it uses the 2 wires that come out. And this is the other 3, and they use the ground and the 3 wires that come out. And look at that, we got some interesting prehistoric inhabitants that lived on this thing. So the next thing I'm going to do is check these tubes, because I already got order the rectifier tube. I might as well go ahead and check them and see if anything else is bad. And we'll start with this power tube, since it was in the wrong place, 6F6G. So go ahead and check the tubes and we'll continue. Well, here's a chance for me to show off my cool TV picture tube tester. It's a Fedro Jiffy tester. And basically it tests tubes and fuses. And if you put a fuse across there and the fuse is good, the light comes on. On tubes, you plug them into the corresponding sockets, and if the filament's good, the light comes on. So we know the filament on this power tube is still good. And I just thought you might like to see that. It's kind of a cool little device. It was made in Japan, 1960s. Tube tester. Of course, that's not quite what I would call it, but that's what it claims to be. So, Jiffy tester. Okay, I checked all the tubes, and what I found is most of them are good or okay. They're at least 65% up to 73%. That's good, with the exception of one, which was down to 20%. And it's bad. Excuse me, and that's the 6F6, of course, because somebody plugged it into the rectifier socket and apparently fired it up there with that high voltage coming from the transformer. So that tube has to be replaced. I have to order a 6F6, and I have to order the rectifier tube, which is the 5Y4. So I got to order those 2 tubes, 6F6 and a 5Y4. And like I said, we could go with a 636, but I'll check and see what's available out there that tests pretty good. And I'll order those this afternoon. And the next thing I can do is start recapping this. I'll probably have to get some caps. I don't think I have any that low. You know how it is when you're working on these antique radios. They got these very low capacitors in the circuit. So we need a 12, a 2, a 6, and an 8 at pretty high voltage. The only one that's low is the 6. I'll see what I got, but I'll have to order those too. So I'm going to put an order in for that and then clean this out. Get it cleaned while we're waiting for it to come in. I love the finish on this chassis. That's just such a nice finish. So I'm going to clean all of this out and all of the covers. This one's loose because it's, I don't know, it's just a little loose, but I can tighten it up. The rest of them were fine. So I'm going to go ahead and do that, get it all cleaned up and ready to go. Check that pilot light and make sure it's okay, and go from there. I hope you found this video interesting, and this should be a very good series on this unit. So you might want to subscribe and hit that bell so you get notifications, and give it a thumbs up. I appreciate any support you provide. Thank you and have a blessed day.